So we will be reversing. You can see here the plus is connected here, so that's also I will reverse here and reverse there. That means we by reversing these things, what I'm doing, that means I'm applying negative voltage this one, so this voltmeter should show negative voltage there. So negative voltage should cause opposite direction. The positive voltage was making a clockwise rotation. So if I give negative voltage, it should be rotating in the reverse direction. That is what we will be observing, I guess. So let me go back. That is the okay. And turn on the power supply to 5% and then apply to 50 and then 50% and recording the data. Okay. So what is this? 34. Okay, this is too. Maybe the video got truncated. Let me check whether I can finish it off or not. Let us see here. So I'm wagging my tongue too much, I guess, taking too much time. So let me quickly I'll erase this one, the previous data, and then apply 5%. So no high. So if I apply 5% here, you can see the rotation is in the counterclockwise direction. The hole is rotating in the counterclockwise direction there, and then if I apply to 50% and then record the values there, and then reversing the direction, that is control V. So the direction is counter clockwise direction. So what we can observe here, negative voltage gave the negative speed, but it gave the positive. This is the opposing torque still, because of the sign change. Negative speed means it's positive torque we got here. So positive speed gave negative torque here, and positive voltage. Positive voltage gives positive speed, but negative torque here. And essentially at the same 50%, they are essentially the same values, more or less. There's small changes there, but the essentially they are same. And the direction of rotation is different kind of thing. And what is the next step? We'll record this, turn off the power, and then we'll study the speed versus voltage and frictional torque kind of thing. So I don't know this video. Let me continue for some time to make another video. Let us see how it works. So then we'll study the speed versus voltage and frictional torque. So this is because of frictional torque, it's opposes generally opposing torque. The negative symbol will be there. And the circuit modification consideration figure 1.0, that means we'll be reverting back to the same position there. So turn off the power, and then so I'll change back to the normal. So the red terminal should be connected to the 1, and the black should be connected to the 2, and this voltmeter will be reversing. So that is the original circuit here. So original circuit has got the red one, red black, and then red one and black one 2. So we'll create a data table E1 and T. I think the same thing we already programmed here. So I'll just erase the data right now here, and E1 T and N is there, so that is fine. It's asking to leave the first row blank, so we'll leave the first row blank. We'll take the recording from the second row. Okay, then what is this one? Powering up and speed matching. So the powering up and speed matching we do every time with the circuit when we change things, and then we'll take the measurements. So what it says, there is a note here. We will not be doing anything, just this is the informational item here. In this step you will be setting the speed using the prime mover speed. That means we will be using this display to set the speed. This value should be displayed in meter n in lab volt. So same value should be displayed. If there is some big difference, manually enter the values. So if it is small difference, then we will ignore that one. So in our case, the difference is not much, so we will ignore that one. So on the power supply, adjust the voltage control knob so that the prime mover speed increases from 0 rpm to 2100 rpm in steps of 300, and each setting will be recording the value and then turning off the power and plotting the graphs. So we'll do that one. So we'll first finish these ones first. So I will go back to the metering window, and for the speed matchings I will turn on the power and go to 100%, and then come back. So that is the first step, that is speed matching. And then at zero speed we will be taking recording here. So record here. So that is the record there. And then next step is 300 rpm. So in steps of 300 rpm will be ranging from 0 to 2100. So 300 rpm will set here, around 300 will set with economy, if not exactly. So it's showing 304. If I want to try to exactly set, it will take time, so that's why I will, because it's not accuracy here, but we need to have a trend kind of thing. So we'll just leave that one, and here 306 is showing here, 303 is not much difference, so we'll just ignore the difference also. So we'll record it. The next one is 600 rpm. It's very close. 603 is showing here, and then 900 rpm. Our aim is to see, as we increase the voltage, how this speed is changing, whether it is increasing linearly or exponentially, or not changing anything or something like that, decreasing something like that. We will be studying. So from the plot you will be knowing what is happening, kind of thing. So 900 we'll leave it there, or we can adjust a little bit. 902. Okay, we'll take the reading, and then 1200. And then 1500. So you can see that as the speed increases, the noise level increases. $14.96, that's very close. So 1800. $1805, and then we'll apply 2100, last one. So I'm done with the readings, so I'll just reduce the voltage to 0 and then turn off. So that way I can save energy and also wear and tear kind of thing. So I can deal with the table right now. So maybe we have to copy the data and then paste it. So that is the Control S, save. It's not crash, that's good. And I think then I will take what is the next step. So once we record the values, turn off, we did capture the things and then plotting the graph between voltage on x-axis and speed on y-axis. So voltage, this is the input and that is the output. So since it's a prime mover, it needs electrical input and then the output would be mechanical speed kind of things. That's why we'll plot a graph. So to plot a graph, you can see there is a plot graph symbol there. If you click here, and x-axis, I think here, you can put here, x-axis should be voltage, and y-axis speed. So if you see it's linearly increasing, that means there is a linear relationship between the speed and voltage. So that one I will copy and then post in the paste in the, so that is previous one. So I will record it. So exactly, I think it's very 45 degrees kind of thing. That means 1:1 ratio may be there. Okay, so that is what is the next step? So that is, so you ask to put speed, torque, voltage, torque characteristics. That one I just ignored it, but anyway, another plot will draw with torque on x-axis and speed on y-axis. So torque, so this is the electromechanical torque, I guess. So electromechanical torque and then speed. If you see, it has got parabolic nature, that's exponential thing, because it's if there is no negative sign, it will be coming like this. So that is the trend it has. It's non-linear behavior it is showing between torque and speed there. So I think so that one you can be a mechanical guys, they know better than me, I guess. So you can derive the conclusions from this graph. So let me copy and then paste here. Okay, so what is the next step? So now to know the effect of mode switch. So mode switch, what is the effect of, in this part of experiment you will learn how the mode switch affects the operation of the machine. The mode switch allows the machine to operate either in prime mover mode or dynamometer mode. So you'll observe the effect of mode switch in this part. So what will happen, we'll turn on the power and set to 10%. So we'll turn on the power here. So it's rotating here like this now in the prime mover position there. Now on the prime mover and dynamometer, set the mode switch to dynamometer position and wait for few seconds and observe what happens. So if I turn it to dynamometer position, so you can see the motor got stopped. I think it's because the input voltage disconnected. So in the dynamometer mode, it would be expecting mechanical energy from the belt from the other machine. So that's why the electrical input is cut and then they stopped, I guess. Since there is no rotation since there is no mechanical energy from the other machine, obviously that machine stopped there. That is so there may be a question there, you need to answer it. So just I'm giving a hint kind of thing. Okay, so what is that? So we'll record the observation and turn off the power. I think we'll meet you. Oh, prime mover torque. There is another part also in the prime mover section there. So the video, I don't know whether it is getting too long or something. Am I able to finish it in this? Okay, maybe I'll go to the next video and then do that one. So right now I'll turn off the power and then I'll record the observation. I'll meet you in the next video. Okay, thanks.